All right, so the last thing we spoke about, we'll go all the way back up to the top, all right, is adding and subtracting fractions, or better yet, adding and subtracting rational expressions into key like denominators, okay? So when you think about this, the most important thing to do, okay, is that once you establish that you have like denominators, okay, the best thing for you to do is just to rewrite the problem with one denominator and one whole entire numerator. And the reason for that is in red, and that's because the numerator of the second fraction, okay, you want to put that in parentheses so that in case there is this minus sign, you will subtract the entire numerator away from the first numerator. So the really good example that we looked at was right here at the very top of the screen, which is the 4x squared plus 15x all over x plus 3 minus 8x plus 15x over x plus 3. Here we established denominators are the same. So what we did is we wrote the entire problem again with one denominator and then the entire numerator with the 8x plus 15 in parentheses. As long as you can remember to do that, everything's going to be easy, okay? Because you cannot forget to distribute that minus sign, all right? So then we had to refresh our memories on how to find an LCD. Step 1, you're going to write the product of unique factors. Step 2, did I say step 1 is the product? Step 1 is factor each denominator completely. Step 2 is, okay, the LCD will be the product of unique factors from step 1, each raised to a power that is equal to the greatest number of times that factor appears in any one factorization. So the easy one that we looked at was, let me write the fractions here again, 1/8, and I think it was 3 over 22. The numerators don't mean anything. It's all about denominator. So step 1, we completely factored. The 8 turned out to be 8 times 2 times 2 times 2, or 8 equals 2 times 2 times 2. 22 equals 2 times 11. And our LCD is going to be the product of unique factors. So right there is going to be my LCD. The unique factors are 2 and 11, and the 2 appears 3 times in the number 8. The 11 appears once in the factorization of 22. So the LCD is just going to equal 2 to the third times 11, or just 88. Okay? So then we said, okay, well, what happens if we have polynomials? Instead of just a constant, we have polynomials. Well, if you just follow your steps again, all right, step 1, completely factor. Step 2, it's going to be the product of those factors. So, ironically, finding an LCD when you're using binomials or polynomials in general is actually kind of simple. All you have to do is just factor and then write the product of unique factors. All right? And that leads us into, wrong button. There we go. And that leads us into what we're doing today, which is going to be building equivalent fractions. All right, so objective 3. All right, now we're going to do a couple examples of this, because once you see it, I think it's pretty simple, okay? So the goal here is to just kind of think outside the box a little bit. So for example, I have the fraction 1/2. Now notice I left a big space there, so please leave a space. But I have the fraction 1/2 equals another fraction, and I'm being specific here. I want that fraction to have a denominator of 10. So if you think about this, the easiest way for us to do this is to just multiply 1/2 by a fraction so that 2 times whatever this number happens to be is going to equal 10. But here's the thing. We are building equivalent fractions, which means these two fractions got to be the same. All right, they have to be equal. So there's only one number that I'm allowed to multiply a fraction by, and I do not change the fact that the original fraction is 1/2. Does anybody know what that number is? Let me ask the question just one more time. All right, maybe I did a poor job at asking the question. I'm starting off with 1/2. I know that my final result is going to be a number over 10. All right, I got to find what this question mark is. Now, here's the thing. I can't change the fact that I started off with 1/2. And we know anytime we have fractions, you always want to reduce. So what I'm trying to find here is the unreduced fraction that equals 1/2 that has a denominator of 10. So what number am I going to multiply 1/2 by so that I build an equivalent fraction, and I know that if I were to simplify it, I would still get 1/2. So what is that number? Okay, so hold on one sec. Who said 5, by the way? All right, Courtney. So if you multiply this by 5, here's what you get.
5/5.
Ah, thank you. Thank you. You just fixed yourself, which is perfect. So, first things first. We know 2 times 5 equals 10. That's the key to this, okay? But if you just chose to multiply by the whole number 5, you change the fraction. For example, Courtney, you said 5. So if I multiply by 5, I get 5/2, and that's not what I want. The only number that you are allowed to multiply a fraction by and still get an equivalent fraction is 1. I mean, think about it. 1 times 2 is 2. 1 times 8 is 8. 1 times 15 is 15. I mean, you always get the same thing back. The only thing is, because we have a fraction, we have to be very clever on how we write that number 1. And in this case, Courtney suggested, let's write the number 1 as 5/5. And I agree 100%. So if you think about this, let's try another one now. And here's what I want. So I need a number that I'm going to multiply this by. We know no matter what, the numerator and denominator have to be the same because I'm only allowed to multiply by a factor of 1, okay? But I need 21x to the third in my denominator. What is that number? In other words, what's this fancy way that I'm going to write the number 1? Well, let's take it easy. What number times... Well, maybe this will help. Maybe this is why we're stumped. Because I picked a bad problem. Let's do 28. I think that'll make a lot more sense. What number times 14 gives me 28? Ah, okay. So you went all the way home run, and I agree. So the fraction we're going to multiply this by is 2x squared over 2x squared. Notice that's still 1, no matter which way you look at it. 14 times 2 is 28. X times x to the second is x to the third. So I know I've built my denominator, so the numerator has to be 18x to the second. Okay? Are there any questions there? All right. Now, here's why we're doing this. Okay? Eventually, we're going to get to the situation where we have unlike denominators, and we need to be able to build equivalent fractions so that we can make the denominators the same. All right? So let's do one more, and then we'll move on to the next section. All right, so here's what I have. I have 5 over x squared minus 4. I want to build an equivalent fraction so that my denominator is x plus 2, x minus 2, and x minus 3. All right, so what am I going to multiply by?
X minus 3 over x minus 3
How do you know that?
is x plus 2, and x minus 2 is x squared minus 4.
Perfect. So we're going to choose x minus 3 over x minus 3. And the reason being is we should know by now that x squared minus 4 is our difference of squares. So the only thing we need is x minus 3 over x minus 3. Okay. 14.3 is now done. Now we get to the fun part, which actually isn't that bad. Okay? 14.4. We're going to be adding and subtracting. Let me type this in. Adding and subtracting.
For that last part, whenever you write the top of it, do you like distribute?
Yes. Didn't I do that?
No, you skipped that.
Oh, I'm sorry. Why did I skip that? Oh, I definitely did. I was just so concerned with the denominator. I wouldn't even distribute it. I would just leave it as 5 times x minus 3. Okay? Wouldn't even distribute it. Just leave it already factored. Whenever we say something is factored, that is what we were saying is it's completely simplified. Okay? Yeah, sorry about that. I was just so excited about the denominator, I forgot about the numerator. I'll use the excuse it is Friday. All right? So, 14.4 is adding and subtracting rational expressions with unlike denominators. Okay? So, a long time ago, in a galaxy far, far away, you were asked to do a problem like this. Let's do 3 over, how about 2 over 15? Because I don't want them to reduce. All right. So a long time ago, you were asked to do a problem like this. And we said, okay, you need to find a common denominator. And there are all these different tips and tricks and all this stuff that I just absolutely hate. So if you know me by now, I'm a huge fan of prime factorization. So if you went for a second, just watch. To find my LCD, I know I could take 12 and break it down. I could take 15 and break it down. I know the LCD is going to be the product of unique prime factors. 2, 3, and 5. The question becomes, what are their exponents? Well, the 2 is going to be squared, and that's because I have a maximum of 2 2's. The 3 will be raised to the first power, because regardless, in either factorization, there's only one 3. And the 5 will be raised to the first power. So regardless, and that's because the 5 only appears in the 15. That's it. So I know my LCD is going to be 2 to the second times 3 times 5, or what is this? 4 times 15 is 60. All right? Now, here's what, hopefully, let me think about this here. Here's the way that it actually goes. All right? Watch this. So notice here, I wrote the prime factorizations from the right-hand side just underneath in the denominator. Now, I know I need to multiply both of these numbers by something, and my goal is to get 60 in the denominator. So watch this. The first fraction already has 2 2's. In fact, let me do this so you guys know exactly where I'm going with this. So if I look at my first denominator, 2 times 2 times 3, watch what I do. Everyone just watch the screen. This is how easy it is to add and subtract fractions with unlike denominators. Ready? If I can break down that denominator, 2 times 2 times 3, I could put check marks above them. What's the only number that I can't put a check mark around or above? What's the only number? Somebody tell me. 5. So I'm going to multiply the first fraction by 5 over 5. Now I erase my check marks and I look at the second denominator. I can put a check mark over the 3 and the 5. The only 2 numbers that I can't do that with are the 2 times 2, which is really 4. So I'm going to multiply the second fraction by 4 over 4. No matter what, I still get 60 as a denominator. In the first fraction, the numerator is going to be 25. And in the second fraction, the numerator will be 8. Let me write that 8 a little bit cleaner. So the only thing that I need to worry about now, what is 25 plus 8? And what is 25 plus 8? Is it 37? Okay. Is it 31?
33.
There you go. I'm making mistakes on purpose to get you to participate. Oh. Now, anytime we have a fraction, we always want to make sure, is it completely reduced? So, 3 times 11, 3 times 20, for a final result of 11 over 20. Does everybody see what I did there? Do you want me to do another one like this? Okay, I'll do another one like this, all right? Because maybe I went too fast. Let's try another problem here. Let's try 7 over 8a plus 5 over 12a squared. All right, so off to the right. Oh, sorry. Maybe I'm moving too fast. So off to the right, I'm going to try to find this LCD real quick. I could break down 8 into 2 times 2 times 2. 12. 2 times 2 times 3. My LCD is going to be the product of unique factors. 2, 3, in the letter A. Don't forget you have an A down there. So the LCD is going to be the product of unique factors. And now I need to figure out, okay, what are the exponents? For the number 2, in the factorization of 8, there are 3 2's. In the factorization of 12, there's only 2 of them. I need the most. So it's going to be 2 to the 3rd. For the 3, I only see the 3 in the factorization of 12, so that's going to be raised to the 1st. And now for the letter A, if you look at the original denominators, the 8a is raised to the 1st, and then the 12a squared, you got 2 of them there, so this will be 12a squared. Now, what I'm going to do is I'm going to keep this very simple. I'm going to rewrite, or I think a better word to use is I'm going to expand the LCD. 2 times 2 times 2 times 3 times A times A. I just expanded it. Will you not do that, please? Okay? Ouch. From here, I'm going to write 7 over 2 times 2 times 2 times A plus 5 over 2 times 2 times 3 times A times A. Okay? I'm really drawing this out. Once we get into polynomials, you're going to see why I'm writing everything like this. Okay? Now, I need to multiply the first fraction and the second fraction. And my goal is to get these denominators to look like this. This is my goal. Like I said, once we start doing this whole section, you'll see why I'm writing it like this. Normally, when we teach this with numbers, we don't even teach this method, which maybe it's our fault. Maybe we should be. All right, so here we go. I'm going to get out my red marker, and I'm just going to put check marks. So for the denominator of this first fraction, there are 3 2's and a letter A. So 3 2's and a letter A. I need what's ever left over. So what's left over? Can somebody tell me? In other words, what am I going to multiply the first fraction by? Abigail, I saw you unmute yourself. So I multiply the first fraction by 3A. All right, now I'm going to erase my little check marks. And we're going to look at the second fraction, and let's just match everything up. So for the second denominator, I have 2 2's, so a check mark and a check mark. I have 1 3, a check mark, and I have 2 A's. So what am I going to multiply the second fraction by? Can somebody tell me that?
2 over 2.
Perfect. So now that I know the denominators are the same, because I filled in the missing pieces, I'm just going to multiply the numerator. 3A times 7 is 21A. 5 times 2 is 10. And I'm going to write this nice and neat so I have just one denominator and one numerator. Now, here's the stinky part. You actually have to multiply out the denominator. So you got 8 times 3 is what? 24? And 24 times A is going to be 24A to the second over, or that's going to be underneath 21A plus 10. Now you ask yourself, is there anything in the numerator you can combine? Okay, the answer is no. All right. And then you say, can I factor anything? Well, 21A plus 10, there's nothing you can factor there. So your final answer is just 21A plus 10 all over 24A to the second. Does that make sense, everyone? Are we all on the same page? Because now we're going to get to the difficult part. Okay? I don't think it's difficult. But we need to take our time. We need to think about what's happening. So 6x over x squared minus 4. Let's do minus 3 over x plus 2. Now, here's where things deviate a little bit. The denominators here are 2 binomials. They're not just numbers. But my process remains the same. I'm going to completely factor the first fraction. I'm going to completely factor the second fraction. Well, there's really nothing I can do there. okay? Maybe I'll just write it like this. There we go. So my LCD is going to be the product of unique factors raised to their respective exponents. The x plus 2 only appears once in each factorization, so that exponent is going to be a 1. And the x minus 2 only appears once, so that exponent is a 1 as well. So, what I'm going to do now is try to build my equivalent fractions. So, I know I'm going to multiply the first fraction by something and the second fraction by something. I'm going to do the checkmark game again. I'm going to look at my first denominator, which is x plus 2 and x minus 2. I compare that with my LCD. So since I end up putting check marks under both of them, the first fraction, I'm going to multiply it by nothing. Now, if you want, you could put 1 over 1, and that's fine with me. But this first fraction, we didn't even have to multiply by anything because we already have the denominator. The second fraction, if you notice, that denominator is an x plus 2. What I need is the x minus 2. So I put x minus 2 up top and x minus 2 in a denominator. So now I'm going to rewrite my problem with one denominator, and I'm going to rewrite it with one numerator. 6 minus 3 times the quantity x minus 2. And the x minus 2 has to be in parentheses. Are there any questions so far? Any questions? Now, hopefully, before I move any further, well, you know what? Let's finish the problem, and then we'll talk. So my denominator stays the same, x plus 2 times x minus 2. Now my numerator, let's go ahead and distribute the negative 3. So I get minus 3x plus 6. I group any like terms. It's going to be minus 3x over x plus 2 and x minus 2. And I asked myself, can I simplify anything? Since the negative 3x is just one term upstairs, I can't factor anything. So I know I'm completely reduced. All right, now, before I start talking, do we have any questions? All right. I'm going to zoom out here a little bit. All right, that's... Go ahead. I'm listening. Let me zoom in.
Because I feel like I could see myself making the mistake. Why would you not scribble out the x minus 2s?
What do you like? What would I reduce them with?
A 1.
So give me one. Are you talking about? Hold on, Court. Because I don't know where you're referring to. That's the problem with Zoom. I don't know what you're talking about. So, are you talking about here, where I just put this star? Or are you talking about down here?
Oh, I guess, never mind.
Are you sure?
Yeah. I was talking about where that star is right there.
Okay. So you're saying, so if I'm understanding you correctly, you're saying, how come I don't do this?
Yeah.
Okay. So first and foremost, in order for me to do that, everything in the numerator has to be multiplied. And clearly it's not. I have 6 minus. So those, remember, the minus sign, it kind of brings those two together. So the only way that you're allowed to start canceling things or dividing them out is when everything is being multiplied. I mean, let's go back. Let's look at this problem right here. The 35x minus 7x squared over x squared minus 25. I mean, what basically you're saying is, Mr. Float, how come we couldn't do this? All right, watch this. I'm gonna write it in red. This is the exact question you just asked. How come I can't do that? And the answer is, you are not allowed to simplify until you have Nothing but products in the numerator and products in the denominator. Okay? So if things are being added and subtracted, you can't do that yet. That's why we had to go all the way down to this step right here. And if you notice in the numerator, everything is being multiplied now. -7 times x minus 5 times x plus 5 times x minus 2. Does that make more sense now? I can't see or hear you. So, does it make more sense?
Yes.
Okay, perfect. So that's why we don't do it. So, Courtney, excellent question. Because that comes up a lot. All right. Now we're going to start talking. Hopefully now you can see why. Like I said, I got to zoom out a little bit because I want us to compare things. Now, hopefully now you can see why. In the previous example, I wrote out like 2 times 2 times 2 times A, and I compared it with my LCD because what I'm trying to find are those missing multiplications. That's really what I'm trying to find here. So if you compare the previous problem with this problem, did I do anything differently? Or was my process the exact same? I mean, think about what I'm asking. Step 1 for both problems. I wrote the factorization of the first denominator, and then I did the factorization of the second denominator. Then I found my LCD. Then I wrote my my denominators in their factored form. Oh, too much. Okay? Then I compared what my denominators were to the LCD, and I filled in the missing blanks. If you could do that, if you could see that, you're going to be really, really good for this section. So before I move on, are there any questions? All right, we're going to do another problem. Three over 5y plus 2 over y plus 1. Okay? So I'm adding two rational expressions with different denominators. So the first thing I need to do is completely factor each of them. So 5y doesn't factor, and y plus 1 doesn't factor. I got to be honest with you. That's the best case scenario because your LCD is going to be the product of whatever you have. So my LCD is going to be 5y times the quantity y plus 1. Now, I know I need to multiply both fractions by the missing factor. All I do is look at my denominator. For the first one, it's 5y. I could put a check mark underneath the 5y in my LCD. So the missing factor here is y plus 1. So y plus 1, y plus 1. Now I look at the second denominator. That's a y plus 1, so I put a check mark underneath the y plus 1. The missing factor is 5y. So for the second fraction, I'm going to multiply it by 5y over 5y. See, by me multiplying the first one by y plus 1 over y plus 1, I'm really multiplying it by 1. And by me multiplying the second fraction by 5y over 5y, I'm multiplying the second fraction by 1. I'm just really clever on how I'm writing the number 1. Now, if you look, denominators are the exact same. Y plus 1 times 5y, they are the exact same. So, I write it, and I'm going to put the 5y out front because I'm used to seeing it like that. So we write one denominator And let's write the entire numerator. Don't simplify it. Just write it out. 3 times the quantity y plus 1 plus 2 times 5y. Now, if you're wondering where that came from, I'm going to highlight it here for you. There it is right there. Actually, let me even get the plus sign in there. Okay? So now that we wrote out the entire numerator, let's go ahead and simplify. Remember, denominator stays the same. So I need to distribute. I get 3y plus 3 plus 2 times 5 is 10 times y. Now I just group like terms. 3y plus 10y is going to be 13y plus 3 and all that's going to be divided by 5 times y plus 1. Before you circle your answer, you want to make sure you try to simplify. The 13 and the 3, there's no GCF or anything, so there's nothing I can do with that numerator. So I circle it and move on. Are there any questions? April, you have a question? I see you shaking your head yes.
Actually, I was just nodding as in like, okay, that makes sense.
Oh, you're like, okay. The bald guy on the camera's making sense now. I like that. I need to know from everyone else, are there any questions? I mean, my method, my technique doesn't change. Even though every single problem is different, it's the technique that doesn't change. You factor, you find your LCD, and then you fill in the missing terms. You want to try another one? No? What do you think, Carly? Should we try another one?
I think yes.
Okay, I think you're right. I like that attitude. I'm going to remember that when it comes to grades. If you look at the keyboard, the letters D, F, and C are all really close to each other, Carly. But you're not going to be anywhere near there. I'm going to give you an A because you wanted to try another example. How's that sound?
Sounds good to me.
What time did you go to bed last night?
I actually went to bed early, but I'm still tired.
You overslept. You got to find...
I think I did.
No, you got to find that magical number of sleep hours. For me, it's like 4 or 5 hours. If I sleep 8 hours, I'm groggy the whole day. If I sleep 3 hours, obviously that's not enough. You got to find that, whatever that is. Whatever that number is.
My number is infinity.
Why do people love sleeping so much?
It's relaxing. So much fun.
But don't you want to like experience life?
No.
No? Okay. Okay, we gotta find you something fun to do then. So let's do this problem. Now, this one, it looks like the denominators may be the same. You got 6 over x minus 5 minus 7 over 5 minus x. Now, they look like they're the same, but they're not. You know me. What would Mr. Float do in this situation? Let's see how well you know me. What would I do first? Remember, I like to take my time with stuff, so I'm not going to rush. What would I do first?
Would you rewrite it to where the X is first?
And why would I do that?
It's easier to read and get the visual.
100%. I would rewrite it. I like to see the variable first, and then the number second. And what I've noticed here is that my denominators are just the exact opposites of each other. I mean, the first denominator, you have a positive x. Second one's negative x. For the first denominator, you got a negative 5. For the second one, is positive 5. They are the exact opposites of each other. How do I make sign changes in the world of factoring? Because they're the exact opposite. And I know I can change signs whenever I want, but how do I do that?
By -1.
Say that again, Courtney.
Multiply by -1.
Everybody always says multiply. And it's not that it's incorrect. It's just, it just doesn't make sense. I mean, it makes sense to me, but then it doesn't make sense to me. I mean, this entire chapter and the previous chapter, we did one thing, and that was the word factor. And all of a sudden, you throw in a multiply to me. So what we're going to do is we're going to factor, Courtney, a -1. So watch this. I'm going to go ahead and factor a -1. Now, I do notice something here. Something jumps up at me now. Could anybody see what that thing is? Hold on one sec. I'm trying to move my light. All right, maybe that'll work. Yeah, it's not too bad. Let me try to brighten this up. Oh, wow. Looks like I'm teaching in a dungeon. What is that thing that jumps out? Anybody see it? I mean, for me, it's like, oh, I see it. Now, this just comes with practice, so. I have two negatives back to back. What does that become? Go ahead, April. Say it.
A positive?
Positive. Very good. So notice this problem was actually a lot easier than we thought. All you had to do is factor a -1. And when you factor out the -1, denominators stay the same. And you had a negative and a negative back to back. So 6 plus 7 is 13. I need to get one of those ring lights like they do in TikToks. You know, anybody familiar with those ring lights? All right, so with your phone, because that's how they make their TikToks, they have like a stand, and there's a big ring around it. It's a light, and the light just shines forward. That way, when they're doing their dances, you know, they're doing their dances or whatever. Or what's this? What does this mean? Where they just take their fingers and they go like this, and they go real slow like this. What does that mean? Is it bad? All right, after class, somebody tell me what that means, all right? Because I see this a lot. They go, and I'm like, how is that even like a thing? I don't get it. Does anybody make TikToks? My wife makes TikToks just of our dog, though. That's it. Already, he has his own face page and everything. Or what is it? My face? Facebook. I don't do social media anymore. I just do Twitter. That's it. Molly, my wife, she handles all my social media accounts. Man, you guys gotta liven up a little bit on Fridays. It's Friday, for crying out loud. Let's try another problem. I mean, it's Friday. It's supposed to be like, for some of us, payday. For others, it's like the weekend is gonna start. And Carly just wants to sleep. I mean, it's going to be beautiful. Carly, don't you have like a little brother or a little sister? Or like a niece or nephew? I remember.
Yeah, I have a little sister, but I work today. I work all day.
Well, you work all day and you do retail.
Yeah, it's the worst.
Abercrombie and Fitch.
No.
New Kids on the Block had a bunch of hits.
No.
No? You don't remember that song? Oh, no, you're American Eagle. That's right.
Yeah.
Yeah, we had the conversation about the skinny jeans. Yeah. Well, I was going to say, take her to the park. But if you have to work all day, I understand. Take her to the park tomorrow then. It's going to be nice tomorrow.
I work tomorrow.
You'll figure it out. So, speaking of figuring it out, why don't you guys figure this one out? Go ahead. I'll give you, it's 8:47. I'll give you until 9 o'clock. Okay, are we ready to go over this? I need to get rid of my window behind me. That's the problem. Watch this, Courtney. Ready? Too much light behind me. So I'm just going to stand here for now. All right. Let's look at this problem. What would be my first step? Somebody help me. What's my first step?
You factor each denominator.
Perfect. I got to factor each denominator. So 5 over. The first one, it looks like I'd factor out an x. For the second, it looks like I need to factor out a 2. So now that I know that those are my factored forms, off to the right, I can find my LCD. The LCD is going to be the product of unique factors raised to a respective exponent. So my product of unique factors is going to be 2 times x times 2x plus 3. And if I notice, the x only appears on the left or the first fraction once. The 2 only appears once. Remember, it's the factored form, okay? So the 2 only appears once, and that 2x plus 3, although it appears in both denominators, it's only repeated once in each. So right here is going to be my LCD, okay? So now all I need to do is just rewrite this. I know, I know I'm going to be multiplying the first fraction by something. And I'm also going to do that to the second. The question becomes, what are those somethings? So the first fraction, what do I multiply by and why?
I put 2 over 2.
And I agree with you. Because when we compare, let me erase the 2 over 2. Here's what I'm talking about. I'm going to use my highlighter. I got an x. I got an x. I got a 2x plus 3. I got a 2x plus 3. The only thing in my LCD that I do not have highlighted is going to be the 2 over 2. So that's what I need to multiply the first fraction by. So give me a second. 1, 2, 3, 4. Now for the second denominator, I have a 2 and a 2. I have a 2x plus 3 and a 2x plus 3. The only thing that I do not have checkmarked is that variable x that is in my LCD. So I multiply the second fraction by x over x. So now my denominators are the same. I'm going to rewrite it so I have one denominator. Come on. And one entire numerator, not simplified. 2 times 5 minus 3x times x. Now I'm going to go ahead and start simplifying some stuff. My denominator stays the same. It's already factored. Leave it like that. The numerator, 2 times 5 is 10. And negative 3x times x is going to be minus 3x squared. So real quick, personally, I would rewrite the numerator in descending order because that's what I like. And I try to factor the top. I notice no GCF. It's a binomial. But there's a plus in the middle. And the x is raised to the second power. So that's the sum of squares. And I know sum of squares do not factor. So there's your final answer. Are there any questions?
Actually, yeah.
Go for it.
Would you, or like, I don't know, because I factored out the negative. I don't know if that's really necessary or not.
It is not necessary. It's okay if you wanted to. So you're saying, and let me make sure, you're saying you did this. I mean, I personally wouldn't take off points for that.
Okay.
I wouldn't. So don't worry about it. Okay? Any other questions? Yes, no, maybe so? All right. Well, I'm going to call it a day. Because there are a couple more problems.